So I will be talking about the QuickMD plugin. That's our group. Our group has been developed it since last year. So the basic idea is to bring NAMD and VMD together. Now you can run them both in just a user graphical interface. So it's much easier. So for example, before you have to do all these steps like step by step, and it's really tedious. But now you can do it in the in our new QuickMD by just like several clicks, and that's it. And now I'm going to show you, give you a quick demo of how it works. And to do this, you need the newest VMD, which is 1.93, I believe. We have a general VMD session, and we go to the simulation and QuickMD. And that's the interface of the QuickMD. And first, we just load up a protein. In this case, I will do the ubiquitin because it's simple. You just type in the PDB code of the ubiquitin you want to load and click load. And it will automatically put the protein into a new cartoon and waters into the van der Waals. And you can simply make mutations to this protein by just click here. As you can see, it's already showed the sequence of the full protein as well as the secondary structures. I'll just do some random mutations here. And if you do more than 3 mutations, it will give you warnings that this structure will not be stable because you did a lot of mutations. So it's actually very good for beginners who are not familiar with the protein structures and so on. And now we have the protein structure ready. We're going to do a solvation. We're going to show it here. For the demonstration, I'll just do the implicit solvent because it's faster. You have the salt concentration there, and the temperature you can choose. I'll just do 0.1 for the simulation time. And we'll do a live simulation. So when you hit prepare, it automatically put the solvation and ions to the system. And if you see the protein structure, it also adds the hydrogen to the protein, because initially it's from the NMR structure. It doesn't have the hydrogen, but now it automatically put the hydrogens there. So everything's ready to go. And then we just hit the start simulation. Yes. So I'll give it the NAMD. As you can see, there's something moving there. The simulation is actually running. Yeah, but now I think it's heating up. We can do a live analysis on the system. Yeah, you can see so this is a live analysis. You can see the temperature is going up as so the axis is the time and the y-axis is the temperature. You can see it's actually heating up. And you can do a lot of things like RMSD, and you can even, let's plot the kinetic energy. So you can see. Like, yeah, I'll show that after this, yeah. So it's that simple.
This is a non-periodic cell, is that right?
No, this is periodic.
Okay.
Oh, but in this case, it's still periodic. It's just not fully solvated, because it's just faster to show it. Actually, have just a few implicit solvent here, but you can do it with fully solvent. Yeah. And I'll finish this one. Now I'll do another demonstration for the steered molecular dynamics. So you guys have seen a lot of the poolings already, but now we get to see how to actually run the steer MD simulation. So same thing, we load up the ubiquitin. And to do the steered MD, we just hit this one. And you can set up a bunch of parameters here. And for the demonstration case, I will pull it really fast so you guys can see it's actually pulling. Let's try 5,000. And you get to select the residue you want to pull. So let's see this one. And you also need to select the anchor residues, which will be fixed in the SMD simulation. So I'll also select a random one from here. And I will hide the water so you guys can see better. So as you can see, this is my pulling point and this is my anchor point. And now I'm ready to run the SMD. Again, prepare the system so that it add hydrogen to the protein and also solve it and add ions to the system. And this is a first step, which is the minimization and heating step for the system.
Does this output all the same files as the standard?
Yes, it's just have an extra step for the SMD. The previous minimization, equilibration is all the same.
Can you change the equilibration?
In here, yes. Which I will show you later. So now I think we have enough equilibration. I'll finish it. Let's start the polling.
Running it interactively like this slow thing can.
What do you mean those like slow?
Does
Like
it
the
take longer to do the simulation?
not really. It's the same. But I mean, I'm running it on my desktop, so the capacity is really low. You cannot run like very long time. What I'm showing here is only like 0.1 nanosecond.
Right.
Yeah.
So if you had a Linux workstation with GPU,
Mm-hmm.
running it from DMD would not make the simulation any slower.
So you mean you still want to run it on your desktop? I would say you're only gonna get like it takes maybe 2 weeks to get 1 nanosecond.
Yeah.
Yeah, and it also depends on the size of your system. Maybe it's hard to see, but it start like pulling. Let's see if I can see the force. Yeah, so you can see there is force being put here. So the y-axis is a force in piconewton, and the x-axis is the time. Maybe I should make it pulling even more faster, but you get the idea that you can do a live thing in the QuickMD. And I'll also show you that the reproducibility, because that's everyone was talking about. How can you reproduce the simulation that the others are running? So by using QuickMD, all the clips you did is saved. I don't know if I can pull that up. So you actually have a log file in the path I just saved, like recording all the steps you did with the QuickMD so other people can reproduce. And you can also, it's easier if there's any errors in the step, you can find it out easily later on. And here are all the the website address for the QuickMD. You can use it, and if you run into any questions in the afternoon, we can always help you.
You said it's 1.9,
1.93. Yeah, you have to go to this website to download the newest VMD. It's not publicly available yet. That's fine. Oh, okay. It will be much faster, especially with the newest version of NAMD. We have the at least 2 times improvement in the GPU versus CPU. So now it's a good time to run with GPU, I think. So is there any questions about the QuickMD? What is it?
The link.
Oh, sure. You can choose, but by default, it's 36. And it will also detect your system. So if you have a lipid, it will find the lipid force field for you. So basically, it has everything in one folder, and it will choose the most updated version. Like if you have protein, it will choose the 36, charm 36 for the system. But you can also make changes in the folder. Yes?
Can you hack this to the 192 version that is?
It will be a lot harder.
Oh, okay.
So you have to basically add the QuickMD into your current VMD. So I think it will be much easier if you just download the newest VMD. It will be automatically in it. Yeah.
Thank you.
Yes. Yes.
Can you also generate the liquid in case of a membrane protein?
Yeah, it's coming in QuickMD 2.0. If you go to that website, it's also there. So we are now putting the charm GUI into the QuickMD. Yeah, and a lot of more things are coming. But right now in the 1.0 version, we just have the SMD and general MD. So no more questions? All right.
Can
Yeah.
you save the script after generating the setup?
What, like?
Like the commands, actual commands that you used?
Yeah, so everything you did will be automatically saved. There's like a log file, like recording all your steps by steps, what you did in the system. Yeah. Yes?
How's that energy minimization done? Like, is there a certain script, or can you do your own script for energy minimization?
So what minimization is, it avoiding, so when you generate your structure, you might get some overlap between those structures and the dihedral, like if, for example, sometimes you have cis bond, sometimes you have trans bond. Those might not be correct. So what minimization does is bring the your protein structure to the lowest energy, so it doesn't have any like artifact in your system to make sure it's stable. That's what minimization does. I don't know how you can do your own script to minimize the system.
I'm using Romex, and you can do your own minimization.
Like you can choose the different steps, or
No, like you have your like you have steep integration, you have your own integration values that you can use.
oh
So I'm just wondering, like, can you do the same here, or is it just
yes,
general?
yes. If it's just changing the parameters, you can also do that in the NAMD. All right, thank you for your attention.